Hello, folks. I'm Jim Fernhaber, the creator of SoftmicaCalc, the world's most versatile Windows calculator. SoftmicaCalc is so versatile because it's really a cross between a spreadsheet and a calculator, as I will demonstrate in this and future videos. This video will focus on the functionality of the primary calculator that appears now alone on the screen. This calculator window is divided into essentially 5 different sections. On the far right, is the visual memory section, consisting of 8 visible memory cells, each of which can display any one of up to 99 different memory sets. By default, memory values are numbered consecutively through memory set. So memory set 1 shows memory locations 1 through 8, memory set 2 locations 9 through 16, and so forth. You can use the bottom memory display selector to display any memory location, no matter its memory set, so long as the memory set containing that value was previously selected, either implicitly or explicitly. The calculation area is in the upper left. It displays values in calculator calculation levels and any pending operations to be performed. Below that is the outline number keypad, operators, and functions section, from which you can enter numbers and select basic operators and functions by clicking on the virtual keys. You can also use your physical keyboard to enter corresponding values. The formatting section allows you to format the way calculator and memory values are displayed. The command section is where you can easily open and close the 4 specialized calculators and 2 powerful processors included in SoftmicaCalc, and open the window to save and recall memory sets. The entire history of calculations performed can be saved to a paper tape by clicking the Save to Paper Tape checkbox. Opening the paper tape window will show the calculation history in detail from the time you check Save to Paper Tape and update automatically as calculations are performed. I'll leave this window open now so you can see how it updates. To begin, let's start with a very simple calculation, adding 2 numbers. Using the on-screen buttons, I'll enter 1, 2, 3, 4.57. As you can see, when I click each key, the number is placed in the box corresponding to the highest active calculation level, in this case, Calc Level 1. When I click plus, the Calc 1 value is formatted and the addition operator appears in the box between Calc Level 1 and Calc Level 2, and a 0 appears as the default value in Calc Level 2, which is now the active Calc level. Now when I click 291.84, that value automatically goes into Calc Level 2 because it corresponds to the second value in the pending binary addition operation. When I press equal, the addition is performed and the result appears in Calc Level 1. Since no other binary operations are pending, the operator box and Calc Level 2 are cleared. As you can see, this addition also appears in the paper tape. In any calculator, there are 2 different kinds of operators, unary and binary. Unary operators are functions that operate immediately on the value in the active calculation level when invoked. Binary operators, on the other hand, require a second value before the operation can be accomplished. An example of a unary operator is the square root function. This function immediately calculates the square root of the value in the active or highest calc level and replaces the value in the calc level with the result. When I click the square root key, the square root value immediately replaces the previous value in Calc Level 1 in the selected format. Now when I press the multiply operator is displayed between Calc Levels 1 and Calc Level 2, and Calc Level 2 now becomes the active Calc level. If I enter 7, that goes into Calc Level 2, and when I press square root, the square root of 7 will immediately replace 7 in Calc Level 2 because unary functions always operate immediately on the value in the active calc level, which in this case is 2. Now if I press equal, the 2 values are multiplied and the result is shown in Calc Level 1. Pressing equal always forces any pending calculation to be executed, and the final result always appears in Calc Level 1. To better demonstrate value formatting, I'm going to add 1000 to the value in Calc Level 1. And I'm also going to transfer this value to memory. memory location 1. As you can see, because this value has more than 3 digits to the left of the decimal place and the comma box is checked, the comma separator is displayed in both the calculator and memory values. If I uncheck comma, the comma disappears in both values, and if I check it, you'll see it again. If I change the number of decimal places from 4 to 3, notice what happens to the right digit. The far right digit is always rounded to the appropriate value depending on the digits to the right of it. In this case, it's rounded up to 8. I'll show you again. This demonstrates how SoftmicaCalc rounds digits rather than truncating them when you reduce the number of displayed decimal places. And finally, if you want to display values in scientific notation, in the decimal format drop-down, the last selection is EX. If you select that, as you can see, the memory and calculator values are displayed in scientific notation. I'm going to reselect 4 digits. Now is a good time to talk about order of precedence. Order of precedence determines the order in which SoftmicaCalc, or any other calculator for that matter, performs binary operations. Take the example of 6 plus 4 times 5. When I enter this into the calculator, entering the multiply operator opens up calc level 3 because the multiply operation must occur before the addition operation since its order of precedence is higher. Once I press equal or another operator of equal or lower precedence, the operation is entered can be calculated. And you can see this in the paper tape where we get the intermediate result of the multiply operation and 6 is added for the final result of 26. Alternatively, if I enter 6 times 4, now watch what happens when I press on plus 5. The 6 times 4 value will be calculated immediately after entering plus because addition has a lower order of precedence than multiply. And then adding 5 occurs in calc level 2 as shown. And again, looking at the paper tape, you can see the 6 times 4 generates the intermediate result of 24, and then when we add 5, we get the final result of 29. In SoftmicaCalc and math in general, the highest order of precedence is equal, followed by the left parentheses, the right parentheses, then exponentiation, then multiplication, division, and modulus, and finally, at the lowest level, addition and subtraction. Here's an example of an expression that chains order of precedence operators to 4 levels. 5 plus 6 divided by 7 raised to the power of 1.8. These operators are chained because addition has a lower order precedence than division, and division a lower order precedence than exponentiation. Pressing equal performs the calculation according to the stated order of precedence. You can use parentheses to override the default order of precedence. For example, if you want to multiply the sum of 2 numbers by some value, you can use parentheses to force the addition to occur before the multiplication. Here's an example using 3 times, now left parentheses, 4 plus 5. Because of the parentheses, the 4 will be added to the 5 before the multiplication, and the result is 27. Pressing equal automatically assumes a right parentheses already exists when doing the final calculation, even though you didn't explicitly enter one. You can see this in the paper tape, which shows the right parentheses and the intermediate value of 9. Now, if you close the left parenthetical expression yourself using the right parentheses, SoftmicaCalc will calculate an intermediate result in the calc level adjacent to the left parentheses. Here's an example. 27 times left parentheses 5 plus 6. Now when I close the left parentheses using the right parentheses, you see the intermediate result appears in calc level 2, and then pressing equal gives us our final result, and you can also see this in the paper tape. You can nest parentheses up to 4 deep, although that is rarely necessary. For multiple parenthetical expressions, the inner parentheses operation will always be performed before the outer, regardless of whether you enter the right parentheses yourself or press equal to implicitly close the parenthetical expression. Note that the clear button clears all calc levels and operators and sets the value in calc level 1 to 0. The clear entry button clears just the value in the active calc level. And the back button clears individual digits on a last in, first out basis, as you can see. The swap button swaps values in the active calc level and the level below it. It's only enabled when more than calc level 1 is active. Here's an example of swapping the values in calc level 1 and calc level 2. The restore button restores the previous value to a calc level after a unary, binary, or clear operation, and will toggle values when pressed twice since the previous calc level is always saved. So I'm going to restore the previous value in calc level 2, and I'll click it twice. You can see that we get it toggles the values. Now I'm going to press equal. The radians and degrees radio buttons determine which unit the trig function is expect in their calculation, and will also convert radian units to degrees and vice versa using the value in the active calc level when you select each unit. So when I press degrees, we're going to convert the value in calc level 1 from radians to degrees, and when I press radians, we'll convert it back to radians, but in normalized format. Now, let's talk about memory. The beauty of SoftmicaCalc memory is that it's visual, just as in a spreadsheet, so you can always see the value in displayed memory locations. You can transfer the value from the calculator active calculation level into a memory location in one of two ways. The most direct and intuitive way is to transfer a value is to simply click the right arrow key corresponding to the visible memory location. In this case, I'm selecting the right arrow key to store 123.45, the value in calc level 1, into mem cell 4. When I click the right arrow key, you can see that value goes into memory location 4. Now I'm going to click plus and then 13.5, but I'm not going to do the addition, so calc level 2 is now the active calc level. The second way to transfer values into memory is with the mem button. The mem button will transfer the value from the active calc level into the first 0 or empty memory location, which in this case is location 1. So when I click the button, 13.5 goes into memory location 1. When I click it again, it'll go into memory location 2 because that's the next empty memory location. I'll complete the addition, and then I'll put that result in memory location 3 by pressing the mem button. As you can see, when I initially transfer a value, it appears in blue for a few seconds in the selected memory location before turning to the default yellow color. This is to show that the value in memory has been set to a new value. If you use the right arrow button and you transfer a value to a memory location that already has a value, the new value will displace the previous value. To transfer a value from memory to the active calc level, click the adjacent left arrow key. Here we will add the value in calc level 1 and the value in mem cell 4. And I'll click plus, and now when I click on the left arrow key for memory location 4, that goes into calc level 2. I'm not going to complete the addition though, because I want to show you that if I click on the left arrow key for memory location 3, the value in memory location 3 overwrites the value in calc level 2, just as transferring a value from a calc level will overwrite the value in memory. Now I'll complete the addition, click on the mem button, and the result will go into memory location 5. What about memory labels? Well, you're not limited simply to numeric labels in memory cells. You can give them whatever label name you want. Let's say we want to assign memory location 4 the label of length instead of 4. To do that, I'll type length in the label edit box and then drag that value over label 4 and drop it And voila, memory location 4 now has the label of length. You can assign new labels to any memory label for any memory location in any memory set, doing what I just did. You can also drag and drop memory values themselves from one memory location to another, as I demonstrate here, dragging the memory value in 3 and dropping in 7. I'm going to take the memory value in 5 and drop it in 7 again. As you can see, the new value overwrites the previous value. There are several ways to clear memory cells. Right-clicking on the right arrow button for any memory location will clear the value in that memory cell. I'm going to right-click on the right arrow for cell 7. As you can see, that clears the value. Pressing the Clear All button will clear all memory locations. First, you'll see a dialog box asking you to confirm that you want to clear. In this case, I will select No, and you can clear checked and unchecked memory locations. To check a memory location, just check the box adjacent to the memory label, as I'm doing for memory locations 1 and 2. You can check all non-zero value memory cells regardless of memory set by clicking the C button. Clicking the I button will invert checked memory cells, and clicking the U button will uncheck all memory cells. I'm going to recheck all non-zero cells. SoftmicaCalc has direct memory functions that operate on either a single cell or a domain of cells. To perform a function directly on any memory cell, right-click over the cell value and select the function to be performed from the list that appears. In this case, I will select the natural log function, which immediately performs that unary function on the value in memory. You can select the domain of memory locations in which you want direct memory functions to operate from the first menu item, as I show you in the display here. The default value is only the selected cell, and the domain you select remains in effect until you change it. In this case, I'm going to select all checked cells. Now when I perform the memory function natural log, the function is performed on all checked memory cells, and I'm going to select exponent to reverse what I just did. As I said, whatever domain you set remains in place until you explicitly change it. There is a redefinable global action memory button, which the mouse is now over, which allows you to add, subtract, multiply, and divide the memory location domain specified in the button by the value in the active calc level and replace the value in memory with the result, actually the values in memory. To redefine the button, right-click on it to select the function you want the button to perform. The display on the button will change to show its new function. I'll set the button to add all checked memory values. Now when I click on the button, the value in the active calc level will be added to each memory location and the new results displayed in memory. And I'll do it one more time. And now I'm going to change the button definition to minus checked, and so now the value will be subtracted, as you can see. There are also local cell memory buttons, which give a lot of flexibility when working with memory values. These buttons are adjacent to memory locations. To define the button function, right-click to select the function you want the button to perform, and the button will be redefined. The default definition is plus, and I'm going to leave it that way for just a second. The plus value will add the value in memory to the value in the active calc level without changing the memory value, as you can see when I click it. I'll do it twice. Here are two other examples of button definitions. The plus right caret definition will add the value in memory to the value in the active calc level without changing the calc level value and replace the value in memory with the result. It's similar to the global action memory buttons, but it only operates on a single memory cell. As you can see, that's what just happened. And finally, the swap function will swap the value in memory with the value in the active calc level. which I just showed you a few times. Now let's talk about save memory sets. You can save, recall, and swap different memory sets by clicking the Save Mem button to open the memory storage window as shown. This means that just as in a spreadsheet, there's really no limit to memory in SoftmicaCalc. You can save and recall different memory sets for different use cases and even print them in a spreadsheet grid-like format, as I show you here, or transfer them to an Excel file. For this demonstration, I'll transfer the values from the selected save memory set, called primes less than 99, into SoftmicaCalc active memory. When I click the Transfer to Calc button, a dialog box opens asking me to confirm. I'll click Yes, and the values will be transferred from memory storage into SoftmicaCalc memory. And as you can see, both memory sets 1 and 2 are populated with the 16 values. I'm going to check 2 of these values and then close the memory storage window. Just as with memory storage, you can print the calculator memory by clicking the Print Calc Memory button, and you get the same nice spreadsheet-like format printout. I'll use these memory values in just a minute. All functions in SoftmicaCalc are available from the main menu. These include memory functions and mode changes, math functions including hyperbolic, financial functions, statistical, and a health function, which is a body mass index calculator, and a whole host of conversions for temperature, distance length, speed velocity, weight, volume, area, time, base, trig, energy, and force, and a number of commonly used scientific constants. You can also access most of these functions directly by clicking on the FX key to open the functions window as shown. This window moves with the main calculator window, although you can move it to a different place if you prefer. However, if you move the calculator window, it will reattach. The top part of the window has buttons for all of the scientific functions. Below that is the tab section, which gives easy one-click visual access to a whole host of specialized functions as well as commonly used conversions. There are 4 tabs in this window. Fin is for financial, Stat for statistical functions, and CV1 and CV2 for different sets of conversions. Let's talk about financial functions. You can access financial functions by selecting the Financial tab or from the Financial dropdown. Each financial function opens in its own window to perform that specific function, making financial calculations very easy to perform. I'll click on the Payment button to open the payment window as shown. And now I'm going to demonstrate calculating a payment. I'll enter 100,000 as the loan amount, interest rate 5.5% for 10 years, and when I click calculate, we get the payment amount, the total number of payments, the total of payments, and the total loan interest. We can transfer all of these values with their labels to memory, but I'm not going to do that, and we can also print the result in a nice printed out format. And all of the financial functions do open in their own window, and as I said, that makes them very easy to use. Statistical functions are available in either the Stats tab or from the Statistical Health dropdown. Statistical functions operate only on values in memory, and the drop-down stat functions operate only on checked memory values. Using the Stat tab in the Functions window will allow you to select the domain for memory values used in statistical functions by either clicking All, Checked, or Unchecked. In this case, I'm going to select Checked, and I'm going to click the C button to check all non-zero memory locations. Now when I click Sum, the sum of all checked memory values appears in the active calc level, which is calc level 1. When I select mean, we get it. Standard deviation, variance, minimum, and maximum. And now say I want to take the average of the minimum and maximum checked values in memory. Well, we have the maximum. I'll select plus. then select minimum, equal, divide by 2, and there's the average value of the minimum and maximum checked values in memory. Many common conversions are directly available in the CV1 and CV2 tabs. To access every conversion, you have to use the drop-down menu button. Conversions are also unary functions that operate on the value in the active calc level. For example, let's assume this value is 63 and calc level 1 is a temperature in degrees Fahrenheit, and we want to convert it to Celsius. I'll click the F to C button, and that just happened. Or to convert it back, C to F. Or say we want to go feet to meters, that just happened, or meters to feet, or pounds to kilograms, or kilograms to pounds. As I said, these are unary operators that always operate on the value in the active calc level. There are 4 powerful specialized calculators and 2 powerful special purpose processors in SoftmicaCalc. There's a date calculator, a time calculator, a date time calculator, a freeform calculator, a function processor, and a very powerful equation processor. I will do separate videos on each calculator and processor, as each is very powerful and deserves its own detailed demonstration. As you can see, when I click on the button to open a specialized processor or calculator, in this case the processor opens, the corresponding button turns green, and a close button appears below the associated green button. Pressing the green button will either minimize or activate the corresponding calculator or processor, depending on its current window state. Pressing the close button will close that window, the close button will disappear, and the function button will return to its original pale blue color. This will also occur if you close a calculator or processor organically from within its own window. Well, folks, this concludes the demonstration of the primary SoftmicaCalc calculator. As you can see, it's very powerful and versatile. You can also watch the separate videos on the specialized calculators and function and equation processor. I hope you enjoyed this overview, and I look forward to seeing you as a subscriber at the exceptional price of only $12 per year or $1.25 per month. Thank you for watching, and have a great day.